Decimal number system. Decimal number system is the base 10 system, and it is the most popularly used number system these days. It is called decimal number system because it is made up of 10 numbers 0 to 9. All the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. In all they make 10 numbers, and that's the reason we call decimal 10. Okay. Now each of these numbers, when we go into detail, the focus here has to be the base of 10. Each place, units, tens, thousands, unit tens, hundred, thousands, or so on, each will have a base of 10, and they will have their own power. 10 to power 0, 10 to power 1, 10 to power 2, and so on. So I will be stressing on that aspect a lot during this session. Placeholder, and then so the placeholder means depending on what the place is of the digit, the value of the power will be. For example, the units place, the value of the 10 power will be 0, and so on. We'll come to that in a bit. Let's focus first from the rightmost digit, which is units place, right? A single digit number, and which is, imagine that number, pick up a number like, for example, 5. Just by itself is, if there is a single number, it exists on the units place. Okay. And if we have to take another number, let's say 325, and then you are asked the question, in this number 325, which number is on the units place? The answer is 5. Okay. Now we have to think about the smallest one digit number, right? So the smallest one digit number is 0. Okay. And the way to interpret is, when we are saying 0, you can think about 0 multiplied by 1, or 0 multiplied by 10 to power 0. Okay, this will still result in 0. Okay, but in your mind, when you see 0 by itself, think about it as being multiplied by 1, or in another way being multiplied by 10 to power 0. Okay, the key thing here again is 10 to power 0, because we are talking about a units place. The base is 10 and the power of 10 is 0. Okay, so units place, the power is going to be 0. Okay, look at 9 also. Do the same thing. Imagine 9 being multiplied by 1, or 1 being represented as 10 to power 0. Now I'm sure in the elementary classes we have all studied, and you must remember, any number to the power 0 gives you 1. So when we say 9 multiplied by 1, you can imagine as 9 multiplied by 10 to power 0. Okay, so this gives us 9. And the important thing here in the case of units place is 10 raised to power 0. 10, because of decimal number, remains the base, but 0 here is specifying or signifying the units place. Okay. Other one digit numbers. Okay, so just so that you are able to hone in into this concept, imagine them as this. Okay, all the way 0 to 9, this is how they will be represented. The common thing is 10 raised to power 0. Remember, one digit number, which is the rightmost, the base being 10 because it is decimal, and the power is 0. Okay, let's move on to the tens place. Okay, now this is a number, this is what is the digit which is second from the right. The rightmost was the unit place, and this is the second from the right. Here in the units place, everything was being multiplied by 1 or 10 to power 0. In tens case, everything is going to be multiplied by 10. Now 10 can be represented as 10 to power 1. Okay. So taking the same example that we took in the unit space, we are taking 325, and now the question is which number exists on the tens place? The answer is 2. Okay, so you need to break in your mind 325 as 300 plus 20 plus 5. Okay, we'll come to that in a bit. Okay, talking about the smallest two-digit number, it is 10. Okay, now let's expand that in the same concept of powers of 10. 10 to power 1 and 10 to power 0. How do we represent it? Okay, 1 into 10 plus 0 into 1. Okay, 1 is the coefficient for 10 and 0 is the coefficient multiplied by 1. Or thinking it in terms of base 10 to power 1 and 10 to power 0, this is how it would look. Okay, gives us 10 plus 0. Okay, largest two-digit number is 99. Apply the same approach. 9 into 10 to power 1 plus 9 into 10 to power 0 gives us what? 90 plus 9. Result is 99. Okay. Again, to again stress on the concept. For the units place, 10 to power 0. For the tens place, 10 to power 1. Okay. Two more example here. Pay attention to these and this will help crystallize your concept. Okay, let's write this. This is common, right? 10 to power 1 plus x plus dash into 10 to power 0. So we have left the blanks for what goes into the coefficients. So this is how it gets filled. 1, 5, 5, 1. Okay, it results in 1 into 10 plus 5 into 1. And here it results in 5 into 10 plus 1 into 1. Results in 10 plus 5 and 50 plus 1, 15, and this is 51. Okay. Move on to hundreds and thousands. Okay. Now hundreds is the third digit from the right. The rightmost digit was unit. The second digit from right was the tens, and now we are talking about hundreds. And just making the same rules for move forward sequentially. First we had spoken about 10 to power 0 for units. For tens place we use 10 to power 1, and for hundreds we are going to use 10 to power 2. Okay, taking the same example again, 325. This will be, what is the number at 100 place? 3. And what value do we get? 300, right? So again, think about it. 3 into 100 plus 2 into 10 plus 5 into 1, or 3 into 10 to power 2 plus 2 into 10 to power 1 plus 5 into 10 to power 0. So that's how you will get 325. Okay. And then we are talking about thousands. Same concept. This is the 4 digit from the right. Sequentially progressing. For units we had 10 to power 0, for tens we had 10 to power 1, for hundreds we had 10 to power 2, and for 1000 we have 10 to power 3. So similarly example 4325. Let's talk about this in terms of visualization, right? So we have this number 4352. What are the coefficient values, right? For 1000 place the coefficient is 4, for 100 place 3, for tens place 5, for units place it is 2. And then when we do the calculation, it is 4 into 1000, 3 into 100, 5 into 10, and 2 into 1. And the total, that's what you get. 4000 plus 300 plus 50 plus 2. That gives you 4352. Okay. Now, think about it in this way. I've written it as multiplied by 1000, 100, 10, and 1. Or it can be represented as powers of 10. 10 to power 3, 10 to power 2, 10 to power 1, and 10 to power 0. Okay. Okay. Now, let's just further hone into this concept. This is a large number, and then this has to be represented in different powers of 10. Starting from right, you can think about it, 10 to power 0 and plus on. How do we represent it? Simple. Give it a try. This is how it will look. Okay. The key thing here is the coefficient of any of these positions can vary from 0 to 9, right? In the first, if the right moves the unit place, the coefficient is 7. 10th place, the coefficient is 8. For 100 place, it is 5. For 1000 place, it is 6. 10,000 place, it is 1, and so on. So it can vary from anywhere from 0 to 9. Okay. So this is where I have changed the color of the coefficient so that you can clearly visualize these coefficients. Okay. Other thing is, remember, in decimal number system, the base is always 10. Look, right, how we are using for units, and again, changing the color for the base to highlight them. They all are 10, base is 10, but the power gradually increases from 0, 1, 2, 3, 4, 5 as we move from right to left. Okay, so that's another important thing that you need to keep in mind and be able to be comfortable with. Okay, taking two more examples, presenting it in a different way. Okay, this is how it is. Think about it. Okay, example 1. This is the number that we need to represent. Okay, how do we do it? We just put them at their corresponding positions. Fill the values which are not 0 first and get those numbers, and then at the same time you can do the zeros also, and they will result in 0 value. So in addition, finally you can add and you can get the number. Okay, and one more example. So this is how you do. Fill the values, and then for the where they are not absent, just put them as zeros. Okay, they will result in zeros, and then you sum them up or add them up, getting the number. Of course, in decimal number system, we ignore the leading zeros. That's why you get this. So the important takeaways here in the for the decimal number system is they use base of 10. Every placeholder, right, has a particular value. Units has a power of 0, tens has the power of 1, hundreds has the power of 2, and so on. Keep that in mind. And then the coefficients can vary from 0 to 9 for any of these placeholders. So if you are clear about it, this is very important that you get clear about it, because the same concepts are going to be utilized in binary number system. And if you make yourself comfortable with this, the reason I'm saying is because we are so used to working in decimal, and so this comes naturally. We can understand this, correlate with this, and hone in these concepts. And once we are clear about it, the same concept we'll apply in binary number system, and then you'll be able to comprehend and digest and understand it very easily. Okay.